Hi everybody. So in this video, I'm going to show you how we can transform a quadratic equation using its roots. So we have a quadratic 6x squared minus x minus 12 equals 0, and this has roots alpha and beta. For the sake of explaining the idea behind this, we're going to work out alpha and beta on our calculator. So if we go into menu, then we want the equation solver, we want option 2 for polynomial, we want 2 degree, the coefficient of x squared we know is 6, the coefficient of x is -1, and the constant is -12. So we can see that we have two roots. Alpha, we'll say, is 3/2, and beta is -4/3. Now we have the two roots, we can sketch this quadratic equation. We know this root will be at -4/3, and this root will be at 3/2. I'm not going to worry about a turning point right now, or the intercept. We're just going to look at the roots. And we've been asked to find the equation of a polynomial with roots alpha plus 1 and beta plus 1. So if alpha is equal to 3/2, then alpha plus 1 will be equal to 5/2, and beta plus 1 will be equal to -1/3. And using these two roots, we can sketch the transformed equation. So this root will be at 5/2, and this root will be at -1/3. So you can see then that the original equation has been shifted 1 unit to the right by adding 1 to each of the roots. And we can work out the expanded form of this new equation using these roots. We'll have 2x minus 5 from alpha plus 1 and 3x plus 1. And this will equal 0. So our expanded form will be 6x squared minus 13x minus 5. And this will equal 0. So I hope this has given you an idea that by transforming the roots of the original equation, we can create a transformed equation. But this method will be much more complicated if we had a cubic or even a quartic equation. So I want to show you a different way using algebra. We know that alpha and beta belong to this equation involving x. So if we say then, let w, our transformed equation, equal x plus 1. So all we've done is we've taken x from alpha and beta, then we've added 1 to it. And we're creating a new equation involving w. Well, if w equals x plus 1, then x must equal w minus 1. What we can do now is substitute w minus 1 back into our original equation. So we have 6x squared, or 6 lots of w minus 1 squared, minus x, which is w minus 1, minus 12. We can expand out this quadratic, so we get 6 lots of w squared minus 2w plus 1. We'll expand out this bracket as well, so negative w plus 1 minus 12. And then we can expand out the quadratic, so we get 6w squared minus 12w plus 6 minus w minus 11 will equal 0. We can tidy this up by collecting the w terms together, so we get 6w squared minus 13w, and positive 6 take away 11 gives us minus 5. And you can see that this is the equation that we were expecting here. Okay? And it is this method which is much simpler when we have equations with higher powers. So in part B, we've been asked to find the equation of a polynomials with roots 2 alpha and 2 beta. So perhaps you want to try this question yourself. You can pause the video, and when you come back, we'll go through the worked solution. Okay, so welcome back if you're ready to go. So the first thing we're going to do is we're going to say, let's say a different variable, let's say t equal 2x. Because remember, the alpha and beta belong to the equation involving x. So then therefore, x must be equal to t over 2. Then we'll substitute this expression for x back into the original equation. So we've got 6 lots of t over 2 squared minus t over 2 minus 12 will equal 0. We'll expand out this bracket, so we get 6t squared over 4 minus t over 2 minus 12. And then we can multiply everything by this 4. So we get 6t squared minus t over 2 times 4 is 2t. And that becomes minus 48. And this will equal 0. We can simplify this by factoring out the 2. So we get 3t squared minus t minus 24 will equal 0. And we can check this works, because if alpha is equal to 3 over 2 and we double it, then this should have a root where 2 alpha is equal to 3 and 2 beta is equal to negative 8 over 3. If we go back to our equation solver, we'll enter our coefficients of 3, negative 1, and negative 24. And we can see the roots are positive 3 and negative 8 over 3. Okay?